Well, everyone, welcome back. So I hope you enjoyed the first half. And if you weren't able to be here for the first half, or maybe you missed a talk or two, something that's looked really interesting to you, we will probably within a day or two have the entire stream split up into a whole bunch of individual videos so you can pick them out, maybe review them, maybe watch them for the first time. For the second half this afternoon, we've got more exciting talks, really talking about cutting edge things that are happening now. Some of those things should give you ideas on things that you can do in order to improve practice within your environment immediately, or maybe give you areas of research, things to think about, maybe things you need to learn more about. The talk we're going to begin with this afternoon is going to be led by a really good friend of mine. And Ismail, I think we have known each other, it's got to be almost 25 years at this point. It is a long time. I couldn't believe it was so long. And I think Greg is doing this talk with you today, right?
Yes, if he's around, I see him
There he
there.
is. There's Greg. So we're real interested to hear what you've got to say. AI powered Blade Runners, the role of AI in implementing zero trust. So please take it away.
Thank you so much, Dave, sharing just my screen here. Yes, and I'm very excited about talking about this topic. Some of you that have been, following me and Greg for the last few years, you know that we have zero trust issues, right? We have been talking about zero trust for a while. That's also the topic of Security 530, defensible security architecture or a journey towards zero trust. But of course, we had to talk a little bit about what's happening out there today in the world of cyber defense. You've seen a lot of talks going deeper into applications of AI. And that's what we're going to be discussing here in this brief time, just talking about some practical use cases, right? We're not going to go as deep as Dave, or we're not going to go into the details of these machine learning models. He's got a fantastic class to learn all of that. We're just going to focus on some applications and how they fit within the overall zero trust architecture. So Greg, why don't we just briefly start talking about that? What do we see here? Is this a Blade Runner? What is a Blade Runner?
Actually, Ismael, when you first shared the image with me, I could have sworn that you gave a chat GPT or image prompt like your picture to create from. It looks a lot like you.
Well, that's interesting, right? Is ChatGPT able to craft images based on your profile? It says that it cannot, but let's see. We're going to look a little bit about what some of these LLM models can help us with, and not just LLMs, because we're going to look at the difference between the LLMs and other predictive models and how they can, they're really different tools, right? That can be applied to different things. So since we're talking about AI here and essentially LLMs, I was just like, what would Copilot say about this question? This is a question that I often pose to the students. Probably, Greg, you probably do the same, right?
Yeah.
Are we winning in cyber? So what do you think that Copilot in this case said, or what would ChatGPT say? I'm looking at the Discord channel here. So let's see if we have some guesses. Looking at my audience here in Discord. People say, nope, we're not winning. Okay. I can do that, Dave. We are winners. Okay, so we have a whole different spectrum of answers. Let's see. This sticker I added myself, right, to the slide because I think we can all relate to that. I like that, John. Yes, we're winning, but we need to win more. We cannot stop there. Look at their response that comes up with Copilot. The battle rages in the digital realm, where ones and zeros clash in a perpetual dance of offense and defense. Whoa. But fear not, the white hats persist, the ethical hackers, the tireless analysts, the guardians of the digital gates. We dissect malware, trace IP addresses, and fortify our networks. Wow, isn't that the topic of this fortifying our defenses, right? Webinar. I love it. So are we winning? It's a delicate balance, a perpetual dance. Victory lies not in eradication, but in resilience. Greg, isn't that what zero trust or defensible security architecture is
supposed to be about? Yeah, it's actually, this is very poetic. Like they're pulling in a lot of like wishy-washy kind of like, dancing around the topic stuff. But what I would have liked for Copilot to come back and say is, here's what we could do to win, right? It's a little bit
Right.
beyond what you asked it. But, we talk about in class, hey, when we are defenders, right, we need to rethink about what winning means. We need to change our perception on it. Sometimes you hear people say, oh, red teaming is so easy. You only have to be right once. Blue teaming is so hard. You have to be right all the time. And that's not really the way that it should be. If we take control of our environments, we've got the home field advantage. We can win because we can architect, we can put the defenses in place, the tripwires, the warning bells, the things that the attacker is stumbling around in the dark. And as long as we stop them before they get to their actual final action on objectives, we win.
Exactly. Exactly. And that's exactly what we discussed in Security 530, right? How we can architect not just with defense in depth, but also with detection in depth, reaction in depth, and as we go through towards this journey of zero trust. Now, unfortunately, many identify with those saying in Discord, I can't name the last win I had. In many cases, because our architecture reflects this old paradigm, right, of the perimeter-based security, where the attackers are on the outside, or as we like to highlight here, that we have a perfectly compliant, 100% compliant network architecture, right, or endpoint architecture. Look, I did everything that NIST said I had to do, where I did everything that Gartner said I need to do, where I did everything that my vendor said that I need to do, and yet I'm still losing. How is that possible? With enough coffee, anything is possible. I totally agree with you. Absolutely. But we're going to need a little bit more than coffee, right? And that's why the zero trust model was created, or the framework, or the strategy, because that's what it really is. Something that Greg and I, we usually point out when we talk about zero trust is that obviously this has become like a buzzword, right?
Yeah.
And one of the reasons that this has become a buzzword is because, as Forrester acknowledges here, they kept these original zero trust papers that were released in 2011, right? Long time ago, behind a paywall. So only vendors saw these documents, and they started to flesh out the narrative around it. So as a result of that, everybody has seen zero trust through the stained glass windows of the vendors' marketing. Now add AI, right? The hype around AI, and then we have two buzzwords there that are maybe difficult to combine in anything practical. But what is really zero trust about? What would you say that zero trust is about, Greg?
Well, the way that I would usually characterize it is that, it really is just a no fooling implementation of the principle of least privilege, right? It's like, but we implement that principle like everywhere, every request, every user, every asset. Like we trust no one, trust nothing. And as you have on the slide, what that results in is, or what it really boils down to is a strategy, a method, an approach to reducing the implicit trust throughout the enterprise. Trust no one, trust nothing.
And of course, this is never going to guarantee like 100% victories, right? We're never going to have that. But this is a model that will help us to mitigate or minimize the impact of these attacks. I like that this points out that it's one strategy that we can work towards, but without an ultimate end state, right? So we're never going to have a 100% compliant zero trust network.
Yeah.
Now, that's a very quick definition of zero trust. We don't want to bore the audience with this. How about AI? What would you say, Greg? What's the difference between AI and machine learning? And
Oh, the
Dave
difference.
Holter, please close, your ears. Like, don't hear this.
He's gonna critique our definition here, or my definition. AI and machine learning. AI is the automation component. It's the thing that takes the information and says, okay, I can do X, Y, and Z for you so that you don't have to, based upon the information in the context of AI ML that machine learning has gathered from the data set that it's analyzed and said, okay, based upon this huge volume of data that you've given me, I can pull out the threads. I can, extract useful pieces of information. It's AI ML together. I always think of as, keeping people from wasting their time, right? Anytime you've got somebody whose job it is to do the electronic equivalent of moving paper from one side of the desk to the other, that's a waste of human capital. And AI ML helps us with that.
I'm going to be like ChatGPT here. I'm going to play the ChatGPT role. I'm going to try to summarize what you said, Greg, into this, meme, which is a joke and it's not, right? I usually joke around this in class. What's the difference between AI and ML? If it's written in Python, right, most likely machine learning. If it's on a PowerPoint deck, most likely AI, right? And talking about the vendor hype. Now, this is kind of a joke, but the reality, as you said, right, and I think others have talked about this before, AI encompasses a lot of these different algorithms and technologies, including machine learning, right? Deep learning is a subset of that. And when we talk about ChatGPT or the co-pilots, we're talking about generative artificial intelligence, which is essentially the ability of the machine to generate, new content, text or images based on these trainings. But these have different purposes, right? Not all AI is the same. And I think a lot of people confuse this these days. So for the purposes of defensible secure architecture or zero trust, how would we use these different tools? Generative AI, right? This is the one that will chat with you, the chat GPT. This is good for summarization, for threat intel context, for assistance. I'm going to do a demo of what we can do in terms of, like, for example, threat modeling, which is an important step, right, in architecture and engineering. We're going to look at how these chat GPT, LLMs, large language models can help us here. This will not stop attacks, right? This is not going to prevent anything. It's not going to block anything. It's a prompt that we're using to, or a technology that we use to make sense of large amounts of data, summarize and provide context.
Yeah.
How about the
synthesis?
Yeah. How about the other side? I know you're going to do a demo on that.
Well, the machine learning piece, then, yeah, we'll do a little bit of a demo, or at least an introduction to what you can do with that. That's looking at these massive amounts of data that we have to analyze and try to find the anomalies, try to find the useful things, try to find the threads to pull on. And the simple truth of it is there's so much data, there's so much information that we're overwhelmed with, bombarded with every day, that there's no way that an individual or a reasonably sized team can find every single one of those variations of unusual things and threads to pull on. So the ML part of AI can look at that stuff and find those threads, pull them out and present them to us so that we can go, that's interesting. Let me follow up on that. Or if we want to automate a little bit more, depending upon the level of confidence we have in what the ML is pulling out, or what the AI has been trained on with, or the ML has been trained on, the AI is pulling out, perhaps automate a defense where, oh, nope, I have a high degree of confidence. That's unusual. That's suspicious. Block that, and so on.
Excellent. So let's look at some applications of that. We're not going to go in depth going through each of these pillars. By the way, if you look at this URL, I wrote recently a blog post on, actually a series of blog posts on how to implement all of these things. But just focusing on the pillars, right? Identity, device, networks, application, and workloads, data, sustained by these capabilities, right? We can call them capabilities that go across all of the different pillars. Visibility and analytics. Analytics is a great example of where AI, or more specifically machine learning, can help. Automation and orchestration. I think you talked before, right, Greg, about that automation layer. And then, of course, governance and compliance. We can't forget that. So, for example, we have talked. Dave opened up the sessions today talking about malware detection. We have seen how it can be used for open source intelligence. Here, in the context of zero trust, one of the key fundamental concepts is adaptive trust. The ability to get signals from all of these different sensors that we are going to architect with across all of these different pillars, right? Think about network sensors for visibility, for detection. We're going to have endpoint sensors for visibility, for detection. We're going to have these across users, right? Identity, applications, the data itself. Zero Trust is a data-centric model. And then getting all of these signals and then implementing a continuous risk evaluation policy, right? So essentially getting all these signals and trying to calculate what's the adaptive trust. Instead of saying, oh yes, we know Greg, right? Greg has access to the database. And then we don't check again if you should continue having access to the database. We're going to continuously check, what is Greg doing, right? Based on a profile that we have created for your behavior, for your user, for your device, and the context around that.
Yeah, Zero Trust has this concept. Even if you go all the way back to the Forrester publication, 2010, there was some documents or some books that came out shortly after that were focused on Zero Trust networks. Zero Trust has this concept of a network agent, which at this point we would just call it the trust agent, right? But it's not an agent you install in a system. It's a logical construct of every single piece of information that you might need to make a trust decision goes into that. And it is absolutely variable because the information you need changes over time of day. Where are you coming from? What have you done recently? How, suspicious is your previous activity? So absolutely comes into play with that trust over time, making decisions on an adaptive basis.
Exactly. Well, let's show some practical examples, right? For example, in Security 530, we talk about the DARIOM model. This is an architectural lifecycle that we use to guide our activities. And we say that starts with discover, assess, redesign, implement, operate, and monitor. So that covers the entire architectural lifecycle, including security operations too, right? So we start this discover and assess journey with discovering what are the threats that we need to care about. One of the things we say is you cannot defend all your assets against every single threat. You need to prioritize. One of the things we do is we start building a threat model based on MITRE attack. And we use tools like, for example, Detect. And Gene McCowan actually did a very good presentation on this a few minutes ago on how to use Detect. So what we have is the defender side, we have the BladeRunners, right? We need to profile the attackers. In this case, these replicants that are going to attack, Tyrell Corporation, and we need to defend Tyrell Corporation against this type of attack. Any BladeRunner fans here in class, right? We're hearing
you don't have to be a fan of the movie in order for it to make sense. It's just fun.
Exactly, it's just fun. So this is what the traditional approach would be. Would look like, or the approach that we can follow. And we actually recommend following this because, as you're going to see, there might be differences when you go full AI on this process. Let's have a look at some tools. The idea is to profile what the attackers look like, the ones that we're going to focus on. Imagine that Tyrell Corporation has a subsidiary that is selling replicants, right? And they have online presence. They also have physical retail stores. Look at that. You can go and buy your Nexus 8, your Nexus 9, your, whatever latest version of the replicant is. So as cyber defenders, we need to figure out what's my threat model. Well, I could use, for example, Jupyter Notebooks. And I'm going to start sharing some links here on Discord so you guys can follow along and see the resources I'm going to show. Very quickly, Greg, can you confirm you can see my Jupyter Notebook here?
Yep.
So what this does is it takes the latest version of the MITRE ATT&CK Enterprise, and this is 14.1. It uses pandas data frames. We're not going to get into the details of all of that, but I start doing some statistics, basic statistics on this, and sorting the data, manipulating the data, exploring it. And I say, look, tell me all of the groups, all of the threat groups that have in the description the word retail. And I get I come up with FIN13 or financially motivated groups, FIN13, FIN6, FIN7, FIN8. Great. So now we have scoped what are the threat actors that I should be looking at. I can still look at the attack matrix and say, hey, look at all the weapons or the software, the tools that this FIN7 group has used, right? Cobble Strike, Griffon, Half-Baked. I can summarize them. I can even do like some little graphics, but it takes, some effort. You need to know a little bit of the coding. Yes, there is also Pandas AI now that you can use. But how could we use large language models for this purpose? Well, let me, for example, drop this in here. I was playing around with ChatGPT, and I created a custom. I'm just using the playground, right? The system playground to say, hey, I'm going to feed you with the MITRE ATT&CK matrix, same thing I just did before. but you are an AI assistant expert in cybersecurity, threat intelligence, and MITRE ATT&CK, assisting the SANS cyber defense community in understanding cyber attacks. Cool. So after feeding this with a JSON file, I said, hey, look at all the organizations based on the description, including each of the groups. Tell me which groups have targeted organizations in the retail industry. Interesting. Look at this, Greg. It's going to take some time. It's going to go through the JSON file, and it will say Fin 7, Fin 6, Fin 13, Fin 8. I had those, right, from my Jupyter notebook.
Yeah.
But then it also adds Group 5 and Dragonfly 2.0.
Yeah. Which, if you dig into the details of those groups, they absolutely have targeted or been adjacent to retail industry, right? So it makes sense. There's just retail isn't in their name, right? It's not in like the categorization that MITRE labeled it or tagged it with.
Exactly. Look at that. It says key terms may include retail, merchant, shopper, store, point of sale. So it went a little bit further, and it did something extra, which may be what you want or not. That's why we need to understand how they work, right? And looking at this type of tests. I can also use the threat intel bot, and I'm gonna share a link with you as well. I'll put it on Slack so you guys can look at it. The threat intel, not Slack, but
Discord.
Yeah. You know what? I'll just do that right after so we don't consume the time here, but I'll share them on Discord. And for example, I'm going to say, describe the tools and techniques used by Fin 7 in a table with the correct MITRE IDs and a description of the tactic and the techniques.
Nice.
Look at that. It's actually populating a table with all the techniques. Well, I would validate that, right? Are all the techniques in here, or is it adding something? You will find that you will have to verify these results. But this is where it gets a little bit more useful. You could say, map each of these MITRE IDs to actionable countermeasures out of the NIST 853 publication in a table. Look at this, Greg.
Yeah, this is awesome.
Again,
I'm in a
it's
rush.
just a
I got to
starting
create
point.
the PowerPoint deck. I got to throw something up for my management. This gives me a starting point.
It gives a starting point. I would not consider this a final result. I would not just go copy and paste this and say, I'm done, as we're going to be discussing later. But you can even go a step further. One of the things we say a lot in Security 530 is, think red, act blue, right? You want to think as an attacker to become a better defender. Hey, give me an emulation plan following Fin 7's TTPs, and tell me what are the tools I can use, right, to implement this. And this is what you're going to get right out of this emulation plan. It's funny because sometimes you ask it to include the tools, and it will not give you the tools. It will give you the technique. All the times it will actually tell you Mimikatz or Cobalt Strike or use this particular tool. So again,
you could take this
before,
a step further, right? You could also feed it the MITRE engage content, the MITRE decept content, right? And say, hey, pull that stuff in and show me what are the countermeasures that map to each one of these things, filtered based upon the information you gave it. Yeah.
Exactly. And one more, I know we're running out of time here, but very briefly, Stride GPT. This is useful not just for applications that you're building, but also for tools that you're using in your environment. For example, I told Stride GPT, I'm going to use Dropbox as a file sharing application for my marketing department so they can share photos and videos from anywhere, including unmanaged computers. So now we're not talking about networking. We're just talking about data-centric security, right? And as you will see, it will generate a threat model here that we can use, including attack trees that we can use as part of our emulations, for example, right? Attack trees. So you can see here, we just created a threat model with improvement suggestions, and you can also include mitigations as part of that. So all of these are useful ways of using these tools for this type of threat modeling purposes. how about architecture? I know there's a lot of stuff we could discuss here, but very briefly, this is the architecture for a zero trust model, right? Or the framework where we have policy enforcement points, policy decision points, and policy information points. The key thing here is we want to implement continuous risk evaluation on the policy decision point, and ML, for example, is a way in which we can do that, right? I think you have a little demo, right? You want to show us?
Yeah, just real quick. And I will try to make this brief because I know we're coming up on time, but just to kind of give you a taste of what can be done. Let me share my screen here.
Yours.
I need to drop your share and then I'll go ahead and jump in. There we go. Excellent. All right. So Ismael, if you can confirm, you can see my screen with a welcome to NGINX in the background. Awesome. Okay. So what I'm going to look at real briefly for you is OpenAppSec, right? OpenAppSec is a web application firewall with some WAP components integrated into it. So web application security in there. And it's, you can think of it as comparable to mod security, the WAF that we're all probably most familiar with. Plus, it has some AI ML components. So what I've done here is I've loaded up a NGINX web service on my computer in a virtual machine, and I've got a application here, which is a vulnerable application, right? So what directory do you want to list? I just put in, look at the current directory, submit that, and it gives me the contents of the web root. And the reason this is vulnerable is because I can do a little bit of command injection here and say, well, but I'd also like you to cat the entire Etsy password file, and it dumps the whole thing out for me, right? So this is before either mod security or OpenAppSec or anything else is installed. Now, in the interest of time, I'm just going to jump over to a snapshot here where I already have it installed. I'll just have to ask you to take my word for it that it took like less than 5 minutes to get it up and running. Just went, downloaded via apt-get not just the NGINX, but the OpenAppSec components, ran the installer for the configuration piece of it, and I'm up and running. Here's this exact same application, which still works properly. If I say, yeah, I want to look at the current directory, then it goes ahead and gives me the listing of the current directory and I can browse around. But now if I say, well, I'd also like to look at the Etsy password, then it says, yeah, I don't think so. Oh, except it did, right? Okay, the demo gods are not with me today. I just tested this a moment ago. It might take a minute for all the services to get up and running, but what's supposed to happen here is that it was supposed to block access to that directory listing and just give me back a blank page. And then if I looked at the error code that came back from the site, that it would give me a 503 error, blocked, right? It would tell me that it was being protected. But if I were to jump up to a later step here, and I'll just go to a later snapshot here where I have a little bit more configuration done to say I want to ratchet things down even further, I can see that I've got a block, but also that there is a potential bypass, right? And that's really what I wanted to show here leading up to the machine learning piece. Yeah, here we go. So I'm in a screen where I have in fact run the query against the site. And if I put in the cat Etsy password, okay, this snapshot should be up and going correctly, right? Then it's because of the services, because of my snapshot, it's waiting for everything to reinitialize. But if it blocks, even though it blocks, then I can still find a way around some of the basic rules. And that's where I get these logs here from the OpenAppSec control panel. and I can see that I've got logs telling me what has been blocked on. Let's see what it found as indicators within the command. So like if I did a cat or I did a, look at current directory, ampersand ifconfig, that would get around the core rule set as it implemented in OpenAppSec. And it's still detecting that there's something unusual about it, but it didn't quite rise up to the level of blocking the communications. I haven't trained it yet. If I wanted to train this properly, then what I could do is I could flip over to the OpenAppSec website, where I can look at logging in with a user ID. If I logged in this case with my Google account, then I would see, timed out on me, then I would see that I have the ability to connect my agent in.
And just while you do that, right, to explain, you could use mod security, which is a traditional signature-based WAF for things like this, and it works. It works pretty well.
Exactly, and it'll work, right? And mod
Right.
security and OpenAppSec are actually using as part of their core the same OWASP core rule set, right? They're implementing it a little bit differently, but what mod security does not have is an AI/ML component, right? Which OpenAppSec does. And I have the ability to come in, say, hey, I've already got an existing agent installed. I want to connect the agent on my host up. If I do that, I get a token that I can implement in, and then I can see the assets that I have available to use. And when I look at the asset information, I have a monitoring piece that I can go into, and I can actually look at the learning aspect of it, where if I want to, I can turn it on in learning mode to say, here's what's normal. Now, the reason I'm kind of jumping through this here and not actually demonstrating that piece is that when you move across the different levels of learning, OpenAppSec wants you to have like a minimum of 900 requests over a period of 2 to 3 days in order to learn what is normal. But hey, Ismael, if you can go ahead and share back on the slide deck.
We need to wrap up. This is like something that can take us actually what, 5 days,
it could
right?
take a while.
6
So the
days.
last thing that I did want to show, and then I'll turn it back over, is you have the ability to say, what level am I learning at? Like basic all the way up to PhD level. It learns more over time. And that last bypass, it can detect just based upon what normal traffic is in the environment.
Exactly. So again, you need to know what these tools are good at and where they fail, right? I mean, you see it. Like sometimes we say, oh, signature-based doesn't work. Well, everything has its place in a defensible secure architecture. You have different tools. You need to know what these tools are good for. And I'm going to quote Dave here because he said something that is fantastic before, which is AI will not replace you, will not take your job. A human using AI will. And very briefly, this is something I did in 2018, working with some data science PhDs, with some big data PhDs. And we talked about the human machine teaming, right? What the human is best at, what the machines are best at. That's our goal, right? To be able to complement the machine and become better defenders by using these tools, knowing where they can fail. And also zero trust, right? Includes not trusting vendor claims. Prove them. And the best way to do this is the think right, act blue approach, right? Get these tools on a range, evaluate them using adversarial behaviors, emulating them, and don't forget the human in the loop. So that's a wrap. All of this is based on Security 530. All of us, Greg and I, we're going to be hanging out in the Discord channel. So if anybody has any other questions, happy to answer them.
Yeah, thank you very much, you two. I mean, I really appreciate it. And Greg, I mean, anyone who's ever done a live presentation, they can understand things go wrong. And I mean, you really got so much in. You talk about this stuff, and not just this, but it's like 6 days of this. What's the typical kind of person who you really recommend Sec 534?
Well, Really, I'll go. The way that we frame it up in class is anybody that wants to be or understand what it means to be an all-around defender, to understand defense in depth. We've had folks all the way from SOC analysts up to program managers who don't do this stuff hands-on, but do need to know what's being told to them and know when stuff passes the giggle test.